Hello everyone, welcome to the course Computer Networks. This is Parvathi, Assistant Professor, Department of CSIT, MLR Institute of Technology. In today's session, we are going to discussing about multiple access protocols, that is part 2. In previous session, we already discussed about what is channel allocation problem, are there, what are the different channel allocation techniques are there, like static and dynamic channel allocations. And next we discussed what are the multiple access protocols are there, what are the different types are we discussed in previous session. Continuation of that, we are going to discussing about multiple access protocols next part. So let us see the overview of today's session. In previous session already we discussed multiple access protocols are divided into three types. These are the three types. First one is the random access protocols, and second one is the control access protocols, and third one is the channelization protocols. These are the three types of multiple access protocols. See, in these random access protocols, in previous session already we discussed about Aloha. What is Aloha? What are the different types of Aloha, like pure Aloha, slotted Aloha, and what are the differences between pure Aloha and slotted Aloha we discussed in previous session. Now we are moving into the next, that is CSMA, CSMA by CD, CSMA by CA. That is we are going to discuss in today's session. First we will discuss about what is CSMA, that is carrier sense multiple access, and next we will be discussing about CSMA by CD, that is carrier sense multiple access, collision detection, and next carrier sense multiple access, that is collision avoidance. These three topics we are going discussing in today's session. First, let us see what is carrier sense multiple access, that is CSMA. CSMA is nothing but it is a method. It was developed to decrease the chances of collision. It is mainly for what? For decreasing the chances of collision when two or more station wants to sending the data over the data link rate. That is the CSMA. Means if suppose two or more stations, two or more users want to send the data to the particular channel, to avoid the collision, at that time to avoid the collision we are going to use the CSMA. What is the CSMA main work is? It requires that each station first, whenever want to send some data, each station, that time first it will check the state of the channel. Means first, whenever suppose this is the user, this user want to send some data to this particular channel. First what it will say? First it will check the state of the channel. First it will check the state of this channel, whether the state is idle or busy. Means any transmission is going on or not, we have to check. First we have to check the state of the channel before transmitting the data. Whenever if the user want to transmit the data, first it will check the state of the channel, whether the channel is busy or idle. Then if it is idle only, it will send the data. If it is busy, it will wait some time. So user first want to check the channel, means user want to sense the channel. Sensing, before transmitting the data, it has to check the channel. That is the CSMA. So it means if the channel is idle, the station can send the data. If the channel is idle, means there is no transmission is going on, then it will send the data. Suppose otherwise, it must until wait the channel becomes idle. The user wait until the channel becomes the idle. That is the otherwise condition. And next, it reduces the chances of collision. What is the main use of CSMA? For reducing the collision, we are going to use the CSMA in the transmission medium. So, what is the main principle of this CSMA is? It is talking about the sense before transmit. Carrier sense multiple access means before transmitting it has to sense the channel. Means or listen before talk. Means it has to send. It has to sense the channel, whether the channel is busy or idle. That is the main principle of CSMA. What is carrier busy is nothing but transmission takes place. If it is busy means what? The transmission is going. Some channel is this particular channel used by some other one. That is the carrier busy. Carrier idle is nothing but there is no transmission currently takes place. There is no transmission in this particular channel. That is the carrier ideal state. This is about the CSMA. Mainly it is talking about the whenever the data transmitting, that time first it has to sense the channel, whether the channel is busy or idle. That is CSMA. And next, carrier sense multiple access modes. What are the CSMA access modes? These are the three types of the access modes. Those are the one persistent CSMA, that is one persistent CSMA, and next one is non-persistent CSMA, that is the second access mode, and third one is P persistent access mode. Non-persistent CSMA, P persistent CSMA. These are the three types of access modes in CSMA. Let us see first what is one persistent CSMA. What is the main aim of one persistent CSMA is one persistent CSMA is mainly talking about the first it will sense the said channel, means whatever channel is there, but first it has to sense the channel. This is the channel. First it has to sense the channel, and if the channel is idle, it immediately sends the data. That is the one persistent CSMA, means it is mainly talking about first it has to sense the channel, and if it is the channel idle, means there is no transmission is going on this particular channel, then immediately it sends the data. Else, suppose it must wait, keep track of the status of the channel. Suppose if this particular channel is busy with some other transaction, so it will wait some other time. It must wait to keep track of the status of the channel idle and broadcast the frame unconditionally as soon as the channel is idle. When the channel is idle, then that time only it will send the data. See this diagram here. This is one persistent CSMA. So this is the channel. When the channel is there, it is continuously checking the channel whether the channel is idle or busy, like that. Means mainly it is talking about it sends the channel continuously. There is no stopping. Continuously it will sense the channel whether the channel is idle or busy. If the channel is idle, automatically immediately it will send the data. The channel is busy, again it will continuously sense the channel. When the channel is busy, when the channel is idle, like that, it will continuously sense the channel. That is about one persistent CSMA. And next one is non-persistent CSMA. What is non-persistent CSMA? It is mainly talking about the transmitting the data. Before transmitting the data, each node must sense the channel. Here also it will sense the channel before transmitting the data. When if it is inactive, means if the state is idle, automatically immediately it sends the data. If the channel is idle, means there is no transmission is going on, automatically it will send the data. Otherwise, the station must wait for the random amount of time, not continuously. In previous case, one persistent CSMA, continuously it will check the channel. Continuous is going on. Continuous checking is going on, one persistent CSMA. And coming to here, it will not check continuously. First it will check, first it will sense the channel. So if it is busy, again it will wait some random amount of time. Means like 5 minutes, 10 minutes. It will take some random amount of time. After that, again it will sense the channel, whether the channel is busy or idle, like that it will check. Again, if it is found busy, again it will wait some random amount of time. There is no fixed time. Random amount of time. It will check again after some random amount of time. If it is idle, then immediately it will transmitting the frames. That is the condition. Non-transmitting is nothing but mainly talking about random. It will wait random amount of time if the channel is busy. Coming to one persistent, it is continuously checking the channel, whether the channel is busy or idle. It will continuously checking, and here it will wait some random amount of time. Again, it will sense the channel. That is the difference between one persistent and non-persistent CSMA. And next one is the pre-persistent CSMA access mode. It is a combination of one persistent as well as the non-persistent CSMA. So here the pre-persistence is also talking. P is nothing but it is talking about the probability. It is a combination of one and non-persistent, and also it is talking about the probability also. Mainly it is talking about the probability. So it defines the each node senses the channel, and if the channel is inactive, means if the channel is idle, it will send the frame with a P probability. With the probability, it will send the frame. If the data is not transmitted, it will wait. Suppose if it is idle, it will send the frames with the P probability. And if it is if the channel is busy, then that time it will wait for Q minus 1 minus P probability time, means it will wait random amount of time, and it resumes the frame with the next time slot. Means first what it will say here, first it is a combination of one persistent as well as the non-persistent. So in this picture, see here, first this is the channel. First what it will do, it will continuously check. There is nothing but the one persistent. This is one persistence. And next afterwards it will again, what we have to say, non-persistence means first it will say some random amount of time. It will check after some random amount of time. If it is busy, again it will check some random amount of time. 1 plus non-persistent is nothing but the P-persistence. Means here it will mainly focusing on the probability of sending the frames. Means wait for the turn. Here also it will say, so here it is the fixed time. Here it is the fixed time. The time slot, whatever time we are waiting, that is the fixed time. Then if it is the ideal, then it will transmitting the data. That is about pre-persistent CSMA. These are the three types of access modes in CSMA. And next one is the CSMA by CD, that is carrier sense multiple access collision detection. Here we are talking about the collision detection, how to detect the collision. Collision detection also in the CSMA. See here, it is a collision detection network protocol for transmitting the data frames. So this protocol mainly works with a medium access protocol. Medium access control layer, it will work. MAC layer, it will work. So it first sends the shared channel. First, it is also sends the channel before transmitting the frame. It will also sends the channel. If the channel is ideal, it will transmitting the frame. Whether it will check whether the transmission was successful or not. That is a collision detection. If the frame is successfully received, the station sends another frame. Suppose if one frame is going to be sent successfully to the receiver, it will send the another frame through this channel. If any collision is going to be detected, means suppose whenever we are sending the data, if collision is happened, if collision is going to be detected in CSMA by CD, means the main aim is what? Here collision detection. If the collision is going to be detected, means there may be cross-talking between two or more users, two or more stations. The station sends a jam or stop signal. Whenever collision is going to be detected, then that time the station is going to be sent a jam or stop signal to the shared channel to terminate the data transmission. Whenever if it is a collision is going to be detected, it will terminate the data transmission. After that, it will wait some random amount of time. If this collision is detected, it will wait some random amount of time before sending the next frame to the channel. Because already the collision is going to be detected. That's why it is again waits for some random amount of time. Afterwards, it will going to send the next frame. The example for these CSMA by CD is 802.3 Ethernet network cables comes under CSMA by CD protocol. And next one is it is mainly compatible with the wired networks. The CSMA by CD mainly talking about the wired networks. See in this picture, first station listens for activity. How it is going to be happen. If detects any activity, suppose if detects any activity, it will wait some time. If it is no activity, means there is no detection is going to be there, it will transmit the frame. Suppose first it will checking about the activity, whether the channel is busy or idle. This is the checking that idle or busy. If it is busy, this is the busy condition, it will wait some time. If it is idle, it will transmit the frames. Whenever we are transmitting that time, if it is any collision is going to be detected. If it is detected some that it stops, it going to be stops or jumps, then it waits again. It is again going to the transmission. Suppose if there is no collision, transmission is going to be completed. This is about the CSMA by CD, that is carrier sense multiple access and collision detection. Means first it will checking the channel. Afterwards, whenever the transmission is going on, it will concentrating on the collision detection. If it is collision, it will stop. If there is no collision, it will transmit the frame. That is the condition. And next one is the CSMA by CA is nothing but carrier sense multiple access collision avoidance. Main first thing is talking about the collision detection. It is talking about the avoidance of See here, carrier sense multiple access collision avoidance network. In this, for carrier sense transmission of the data frames. It is a protocol that works with the MAC layer. It is also works with the MAC layer. So when the data frame is sent to a channel, it receives an acknowledgement. Whenever the data frame sent to a particular channel, first it will receive the acknowledgement to check whether the channel is idle or clear. Whether the channel is clear or busy, first it will check before it will give some acknowledgement to the station. If the station is receives only in one signal, suppose it is giving the ACK, means it is busy or idle, like that, it is giving some acknowledgement. If it is only giving one signal, one acknowledgement, it means the data frame has been successfully transmitted to the receiver. If it is giving the single acknowledgement, means what it is saying? That frame has been transmitted successfully to the receiver. But suppose if we get the two signals, two acknowledgement, if we get, what is he saying? It is on and one or more with the collision of the frame. There may be some collision in that particular channel. The collision of the frame occurs in the shared channel. That is the two signals when we receive two signals. If it is received only one signal, that data frames are going to be sent to the receiver successfully. If the two signals are received, What is that meaning? The collision is going to be happened in this particular channel. That is the condition. It detects the collision of the frame when a sender receives the acknowledgement signal. When it is going to be detected when the receiver receives the acknowledgement signal. It is a particularly important for a wireless network. It is mainly talking about what? Wireless networks, where the collision detection of this alternative CSMA by CD is not possible due to the wireless transmitter. So, CSMA by CD is mainly talking about wired communications, and CSMA by CA is talking about wireless communication. That's why we are reading CSMA by CA, that is collision avoidance. The main example for this is 802.11 Ethernet network cables are the examples for CSMA by CA. This is about CSMA by CA. At the same time, this CSMA by CA is mainly avoided by these following three strategies. How it is going to be avoided? Collision avoidance, right? How it is going to be avoided? Mainly it is having the three strategies. The first one is the interference space, and second one is contention window, and third one is the acknowledgement. This is the picture of the CSMA by CA collision avoidance. See first, what is interference space? Interference space is talking about the station wants to transmit the particular data. It will wait until the channel becomes the ideal. It will wait until the channel becomes idle. When the channel becomes idle, it does not send the data immediately. Suppose in previous case what it is, if the channel is idle means immediately it will send the data. And coming to CSMA by CD, if it is busy, there is no work. Suppose if the channel is idle also, it will wait again some random amount of time. It will not send immediately. First, it will also wait some random amount. It does not send immediately. It will wait some particular time. This period is known as the interference space. After this channel is idle also, it will wait some random amount of time. That particular time is called as the interference space. It is defining the priority of the frame. What it is exactly saying, that priority of the frame station. This is about the IFS, interference space. Mainly talking about when the channel is idle also, it will not send the data. It will wait some random amount of time. That particular time is called as the interference space. And next one is what? Contention window. What is contention window here? Contention window is talking about the time. Whatever time is there, that is going to be divided into time slots. Till here we completed interference space, right? Means after idle also, it will wait some random amount of time. That space is nothing but interference space. Afterwards, whatever time is going to be there, that is going to be divided into time slots. Means when the station is ready for the data transmission, after waiting IFS, after completion of the IFS, it will wait for the ready for the transmitting the data. Then it chooses the random amount of time slots. What it will do after IFS, it will choose some random amount of time slots. This is nothing but random amount of time slots for waiting. It is also for waiting. After waiting random number of slots, these are the different slots, it will going to be wait. This is nothing but the contention window. The channel still busy, then the station does not initiate the whole process again. If the station stops its timer and restarts again when the channel is sent again. If it is going to be idle, then it will send the frame. That is the condition of the contention window. And next, what is acknowledgement? Acknowledgement is talking about there may be chance of collision. If any collision is going to be there, means any data is going to be corrupted during the transmission, it will send some positive acknowledgement and timeout are used in addition. Means what it will say? It will send positive, it will send some positive acknowledgement or it will send timeout message in addition of that. The receiver has successfully received the data. That is the acknowledgement. Whether the whatever channel is we are using, it will send what receiver will do, it will send that the receiver successfully received the data or some acknowledgement like positive acknowledgement or timeout message that will give some acknowledgement to the station. That is the acknowledgement. It is a carrier-sense multiple access collision avoidance network. Mainly it is talking about the carrier transmission of the data frames. It protocols mainly work with what? MAC layer, media access control layer. This is about CSMA by CA. And coming to the summary, in today's session we discussed what are the random access protocols are mainly Aloha. It is already discussed in previous session. Today we discussed what is CSMA, carrier-sense multiple access, and next we discussed what is CSMA by CA, how we are going to detect the collision using CSMA by CD, and next one is we discussed what is CSMA by CA, that is carrier-sense multiple access collision avoidance, how we detect the collision. This is how we avoided the collision during the transmission. That is CSMA by CA. These three topics we discussed in today's session. Thank you.